So in this particular section of the talk, we will be looking into how we can fix slow code. But before we can do that, you need to know how to find the slow code, which leads us to our next topic, which is profiling. So profiling is a program analysis that collects matrices about the program at runtime, such as the frequency and duration of a method call. One of the main goals of profiling is observability. By knowing what's going under the hood during runtime can really help narrow down the scope of performance bottlenecks in the code base to a specific particular area. So before we figure out what we can profile, we need to decide what we need to achieve from profiling. So do we need elapsed time or object allocations? Do we need or time or allocation for every method call, or just an aggregate value? Do we need CPU time or just the call time? To find elapsed time, one solution could be to just find start and end time of any particular code block and just find the difference. But why invent the wheel? We can use one of the available profilers out there um, uh, to do a pretty amazing profiling. So here are some of the popular examples. There is RB Spy, there is Rack Mini Profiler, there is Stack Prof, and there is App Profiler. Each profiler has its own advantages and disadvantages. So explore them, use what fits your need. But by using profilers, you can find out irregularities in different matrices and resource usages of different modules in your code base. You will find what you need to fix. And once you find that, it's time to fix that. So while fixing is highly context sensitive, validating the fix should not be. To validate a fix, we use benchmarking. So benchmarking is a way of measuring the performance of code. Benchmarking helps us prove performance differences between two or more different blocks of code. For example, if you have two blocks of code like A and B, with benchmarking, you can find out which is faster and which is slower. So once you have found a slow code with profiling, you can use benchmarking to prove that your fix is faster than the original code. So at its very simplest, benchmarking could look like something like this. We have some method that we want to find elapsed time of that method. We have a benchmark module in standard Ruby library that we can use to find the elapsed time of any method. So as this code outputs, this method took 1 second. This is benchmarking at its simplest. But Ruby standard library has, and this benchmark module includes some other helpful methods as well, like BM. BM basically splits the elapsed time into multiple different attributes. Like it shows user CPU time, it also uses system CPU time, and some of these two, and it also shows the real elapsed time. So it is more elaborative and more is an other method that comes with standard Ruby library is BM. Sometimes what happens is when you use BM, the results might not be stable, because whenever you run code first time and the consecutive time, the result might be different. So one core difference between BM and the original BM is that it performs a warm-up before it actually calculate any metrics. As you can see on your slides, that it first perform a rehearsal on a given code block, and and then after that it calculates the same address that BM calculates. So it is more organized, and it is used to produce stable results. One other very popular gem for benchmarking is benchmark IPS, which is iteration per seconds. It's not part of standard Ruby library, so you need to add it as a gem. So it actually tells us how many times a code block has run in a given time period, or in a second. For example, if you look at your screens, some method ran almost 1 time in a second and 5 times in 5 seconds. And on cherry on top is it also show a comparison where you can clearly see other method is 1.1 times slower than the sum method. So these kind of benchmarking tools can be used to prove that your fix is faster than the original code. So once you have a proof, it's time to replace the original code with your code. So doing that enough time will make your app a way faster than it was before. So I think that's pretty much it. Before I conclude my talk, let's look back and gather some final thoughts and see if we were able to answer the questions in the agenda.